Welcome everybody, my name is Yan, I'm Director of Engineering from Blueshift. Today I want to introduce you our Elixir Pulsar client. Before I do, allow me to briefly introduce Blueshift, what we do, what kind of problems we're trying to solve, our architectural challenges, and how Pulsar helped us solving these challenges. A little bit of introduction from my team. We're running the Blueshift platform team. One of my team's responsibility is to provide a message queuing solution to the rest of the engineering departments. We've migrated 30% of our traffic from our legacy systems such as NSQ and Kafka to Pulsar in the past 3 years, and this journey continues. About our company, Blueshift is a cross-channel marketing automation platform as well as a real-time customer data platform. We deeply integrate with our customer systems, collecting the first-party data to provide a real-time 360-degree of user picture. We help our customers to engage their users through multiple channels as well as over 100 third-party integrations. What makes Blueshift stand out though is our AI capabilities, such as propensity to purchase, propensity to churn, or send time optimization, to help our customers to engage their users more timely and more effectively. Blueshift was founded in 2014 and headquartered in San Francisco, California. We also have offices in Pune, India and London, UK. We also have data centers in both US and Europe. We deliver massive amount of messages both internally and externally. A modern infrastructure is really just about message passing. We run our transformation, filtering and forwarding logic throughout the system by passing these messages around either synchronously or asynchronously. So you can imagine what kind of challenges we are facing. First of all, our internal messages grew substantially as we added more integrations, work with more customers, and more processing layers, especially for AI computation. Messages don't just come from one end and go out to the other. They are being passed around like a graph, and our model keeps refining, enriching these messages. You can think of every node of this graph represents a real-time state of a user, and we update these states by passing messages around. A good example is how our campaign journey runs. Users can start their journey and being looped through different stages of the campaign with a rich set of triggers, moved from one state to another based on their interaction with the messages or the predictions we have. Next, to provide truly isolation between customers, the number of topics we are creating just went up exponentially. An overly simplified equation could be number of customers times number of processing layers times number of integrations. The third challenge we have is the burst of traffic. Blueshift offers feature like send-time optimization, which allows our customers to engage their users at the best time possible. It's not rare to see large volumes of messages going out at the same time. For example, suppose you're running a flash deal e-commerce site with Blueshift with product recommendations. Millions of messages could be scheduled to be sent out all at the same time. Our legacy system simply couldn't catch up with this traffic and its pace of growth. We used to have large number of Redis instances just to serve our massive job processing traffic. It quickly became unmanageable, so we switched to NSQ. At that time, it offered a very good simple migration. All the message was persistent. It has message redelivery, performed okay. And we also had Kafka in our system to bridge over between engineering infrastructure and our machine learning infrastructure. Problems still exist with this system though. First, none of them provide a truly multi-tenancy, as we have to isolate our customers' resources and make sure no starvation or delay. Naturally, Blueshift traffic pattern is skewed, and you want a system that is able to rebalance itself. For NSQ, it keeps the entire delayed message in memory, whereas in Pulsar, only the message ID will kept in memory, so the actual messages are persisted in Bookie. Also, with our legacy systems, all the topics are treated at the same flat layer. As we pass messages in a graph-like system, keeping track of these topics, producers, and consumers became almost impossible. So we ended up creating more topics, duplicating the data, simply because we don't know if things are going to break downstream. That's why we're looking at a solution that allows us to organize these topics better. And finally, We were in a situation where you have so many clusters spawned together and federated for different customers. So you're just keeping yourself busy managing all these clusters, their versions, and the clients. The list goes on and on. The good news is, Pulsar solves all these problems for us. It's a truly multi-tenant system. It provides isolation between our customers out of the box. And thanks to Pulsar's topic auto rebalancing, our bursts of traffic had never been an issue waking us up at the middle of the night anymore. We heavily rely on the delayed messages. Because of Pulsar, we never needed to worry about the message loss anymore. Our experience with Pulsar suggested that having a good naming convention for namespaces and topics are very important for long term. We use namespace policies to strictly control how topics, subscriptions could be created. Despite how flexible Pulsar allows you to interact with it, we took a different route. We treat namespace and topic creation like a running database migration. So we could keep a clean catalog of topics for different teams to explore and reuse. We also tag the messages with properties so that we don't have to always decode large blobs of JSON for filtering. We could also reuse these topics for highly related messages to reduce the number of topics being created. Finally, we tag our producers and consumers so we can see them from the Pulsar Manager console and telemetry stats. The usage of topics became self-explanatory. As a result of the migration, now we only have one single giant Pulsar cluster shared by all teams for all different services. Other than these advantages I just touched based on, Pulsar enabled us to rethink about our system design and even products. Now, provided with back pressure, dispatch rate limit, message replaying, and message expiration, we were also able to create more in-stream features. Overall, Pulsar helped us to redesign a system that is highly reliable, replayable, monitorable, and made operation of our system much simpler. Enough talking about our migration. Let's talk a little bit about Elixir. Our legacy system was purely written in Ruby. It helped us to get started. At the same time, it has its limitations. So over the years, for those simpler but I/O-heavy systems, we moved them to Golang and Rust. And for those services with complex modeling, we chose Elixir. It plays a good balance between dev efficiency and performance overall. However, there wasn't any production-ready Pulsar client written in Elixir. We had to build our own. Before we started working on it, we had a few requirements in mind. First, we want to be able to optionally handle a batch of messages at a time. For example, we want to handle a batch of 1,000 user profiles to be delivered to an email sender at once. We want to be able to produce multiple messages at a time. We dynamically reuse our topics for related jobs, messages, and multi-purposing these topics. We want to support regex-based subtopic subscription, not just within the same namespace though, but also cross namespaces. Regex applies to all tenants, namespaces, and topics. We want to support custom logic on how to construct partition keys, ordering keys at the time of dispatching, based on the content of the message. We needed a share library to act like interceptors for custom logic that can decorate and running light transformation on the message before they are published to Pulsar. We needed a middleware for consumers, so we can put common filtering, pre-processing logic in one place. Examples could be deduping or error handling. Lastly, in case of any future migration, we wanted client to be able to plug into multiple Pulsar clusters at the same time. Nothing will explain better than a demo, so let's take a look at a recorded demo for using this client. Let's start by taking a look at how we can configure the client first. You start a list of broker addresses and both ports. You can optionally provide a list of default producer and the consumer configurations. For the demo purpose, we're also asking the client to create tenants, namespaces, and topics. This is very useful when you're writing integration tests, by the way. The first example we're looking at is a batch consumer. You can hard-code a bunch of consumer options to override what you have defined in the config file. you just need to implement this handle messages function, which expects a list of messages followed by a consumer state object. In our example, it does nothing but logging the number of messages received in the batch. The expected return value of this function is a list of OK symbols, indicating that the batch has been successfully consumed. You can start your consumer by calling this start consumer function with a topic name and a subscription, followed by the consumer module you defined. Let's see this in Elixir console. The consumer now is started in the background. Let's send some messages. What we're doing here is sending 5 messages asynchronously to the topic that we're consuming. The producer function accepts a topic name, a binary payload, and a list of message options, such as properties, partition key, and ordering key. And you can also provide a list of producer options that you'd like to override. In this case, we wanted a batch producer, and we want to create a pool of 3 producers per topic per partition. Now, the message have been published. As you can see, consumer received them and logged the entry. What if we want to consume from multiple topics? That is easy. We can start consumers by providing regex. Regex can be applied on tenants, namespaces, and topics. In this example, we are going to start consumers on all the demo topics. And then we'll create more messages. Very good. Messages are being received from all topics. Now, I want to make it slightly more complicated. Messages can fail at processing. We want to reprocess the message, and eventually they should go to that letter topic. Let's define a new consumer for that. In this example, we're telling our consumer that we want to use exponential backoff for failed messages and reprocess up to 3 extra attempts. Beyond that, messages should go to this dead letter topic. And for our demo purpose, we're also defining a consumer listening to the dead letter topics. Let's start both consumers. Finally, let's publish some messages. As you can see, the message is being processed for the first time and being reattempted with exponential backoff. And then eventually it goes to that letter topic. So far, what we have learned is how to create a batch consumer with or without that letter topic, along with a redelivery policy. We also learned how to publish messages and create producers on the fly. Next, let's take a look at a more powerful abstraction, a worker module. The worker module looks very similar to defining a consumer. Key differences are that within a worker, you handle one message at a time. You can define interceptors and middlewares. It provides a handful of functions, such as a enqueue function, which allows you to construct partition key, ordering key, or even choose a topic for your message. Interceptors are used when publishing a message. You can choose to skip the message, or you want to decorate a message by adding more properties, emitting logs, and stats before sending it to Pulsar. Middlewares, on the other hand, are common modules that are loaded at the consumer end, where you can put your telemetry, logging, and any error handling logic there. In our example, we're using a dummy deduping interceptor and the telemetry middleware. Let's see this in action. Now, we are starting the worker in the background. Let's enqueue a duplicate message. This message got hijacked by the interceptor and it did not go to Pulsar at all. Now, let's create another message. This message got successfully published, received by the middleware and our worker. You may have also noticed that our middleware actually assigned a hello world argument to the message and made it accessible by the worker module. Why do we need this worker layer on top of the consumer? Well, it's because it allows you to define a workflow from end to end if the producer and the consumer are both in the same app. It's a toolset that removes a lot of scaffolding and the packaged common message handling logic for you, so you can focus on the core business logic. After all, this library offers a lot more than what I'm demoing today. It allows you to write your unit test on the worker without running Pulsar. It also allows you to multi-purpose your topic for a group of related messages, and it emits an extensive list of telemetry stats and logs. You can find examples in the README file of the project or from the online documentation. We've been using this client in our production for the past 2 years. It's a battle-tested client. So today, I'm proudly introducing it to you. Feel free to ask me any questions about this client or our migration to Pulsar, as well as anything related to Blueshift. Finally, thanks for joining everybody, joining this session, and thanks a lot to Pulsar team for inviting us, and I hope you guys enjoy the rest of the day. Thank you.